Good afternoon. Let me introduce myself. My name is Dmytria Danilowicz, and I am a lecturer at the biochemistry department at Polski State University. And the subject of our lecture today is glycolysis. Glycolysis means the breakdown of glucose. And you can see two words. Glyco means glucose and lysis means breakdown. So, and it's also known as Epton-Meyerhoff-Parnas pathway, or you can find in literature EMP pathway. And before we start considering the details of this pathway, I'd like to give you some preliminary information. First of all, this pathway occurs in the cytosol of the cell. And it happens in all living tissues. And this pathway doesn't require oxygen. This is a way to get energy in the form of ATP. And as a result of this path, NADH is also produced. And this molecule, NADH, can be later used to produce more ATP for the cell. And the net reaction, as we can see here, is the result of glucose breakdown. You can see here, this is glucose, and this you can see NADA, and as you can see here, is an oxidized form of NAD, and you can see ADP, two molecules of inorganic phosphate, and two molecules of pyruvates. And here you can see the reduced form of NAD and two molecules of ATP. And now we can start with their reactions. And now you can see the first step. It's phosphorylation reaction. You can see here glucose in a cyclic form, and here also the cyclic form of glucose. And the first step is phosphorylation. And this reaction is catalyzed by the enzyme which is called kinase. I want to remember you that kinase transfers a phosphoric group from ATP, as you can see here, to a receptor, and our receptor here is glucose. So as a result, we get glucose 6-phosphate. This reaction is irreversible, and there are some peculiarities about this reaction. First of all, this reaction traps glucose into the cell, inside the cell. And as you know, for glucose, there is a special transport system, and this transport system can't deal with the charged molecule. And as you can see here, as a result, we get charged molecule. It has two negative charges. And the next peculiarity is that this compound is more reactive than glucose itself. So it can be easily converted into phosphate. And this enzyme needs magnesium ions for its activity. Why is it so? The scientists propose that magnesium ion can form a complex with ATP. So in this complex suits the enzyme better. The next step is catalyzed by isomerase enzyme. And you can see here, it's all isomerization reaction. And maybe some of you think that isomerase reaction is very simple, but as you can see here, it isn't. Isomerase first open the cyclic form of glucose 6-phosphate, you can see here. And you can see here it's open chain form, and you can see here it is aldose, as you can see here, aldehyde group, and it is converted, glucose 6-phosphate is converted now into fructose 6-phosphate here. and glucose and fructose are isomers. And here in fructose you can see keto group. So here we have conversion, the aldose into ketones. And the next step of this enzyme, it helps to get another cyclic form, fructose 6-phosphate, but in this case you can see 5-numbered ring of fructose 6-phosphate. And now the next step is phosphorylation fructose 6-phosphate. You can see here cyclic form fructose 6-phosphate. And this reaction is also irreversible. And here we have ATP, and the phosphoric group from ATP transfers to fructose 6-phosphate, and we have ADP as a result, and we have fructose 1,6-bisphosphate. You can see this molecule is charged even more than fructose 6-phosphate. So it's a more active molecule again. And here, magnesium ion is required for this reaction, and we can go on. And the next step, the enzyme is kinase, phosphofructokinase. Phosphofructokinase is an allosteric enzyme, and it's very important for the regulation of the whole pathway. So the next step is splitting the molecule. Splitting this molecule, and to show this splitting, I prefer to show the open form of the molecule. So it will be this way. You can see keto group. And I can show the way how the enzyme works. And the enzyme is called aldolase. And you can see here, this is the place of splitting. And the first compound is here. And the second compound is here. And you can see both compounds are negatively charged. And the name of the first compound is dihydroxy acetone phosphate, and this compound is called glyceraldehyde 3-phosphate. So now again we have here ketose and we have here aldose. And these two compounds, from these two compounds, there is only one which is used for the following conversion. And this is glyceraldehyde 3-phosphate. So now we have to transfer this compound, dihydroacetone phosphate, into glyceraldehyde 3-phosphate. If we can do it, thanks isomerase. And as a result, we can have two molecules of glyceraldehyde phosphate. And now that is the end of the first phase, so-called consumption phase. During this phase, we only use ATP, but we don't synthesize ATP. So the next phase will be the production of ATP.